Hi, so today we're going to be working with measuring segments and using the properties of the segments and the segment addition postulate, right? So in this case, we're going to start using this figure right here, right? So it says in exercise 1 through 6, use the figure below, find the lengths of each segment. So I want to find the lengths of AB. In this case, is of course, we can just count, right? So this is 1, 2, and 3, and that's it, right? But what happened that if that number of A is small, and then the other one, let's say B is like on 217 or something like that, it's going to be a little bit harder to count. So we can use the formula where A minus B, where A equals the distance from A to B, where lowercase a and lowercase b means the coordinate of this value, right? And we're using the absolute value because we're looking for a distance. So in this case, it's the absolute value of -1 minus -4, right? So this becomes a positive. So this is the same as the absolute value of 3 of, and so this is just 3, right? So on number 2, again, I'm going to go from B to C. So I have 4 minus -1. So this is the same as 4 plus 1. So this is the absolute value of 5. That is just 5, right? I'm from A to C. Again, this is the absolute value of -4 minus 4. So this is the absolute value of -8. So this is 8. So that's it for this one, right? A, D, B, D, and C, D. We're going to do exactly the same, right? So number 7, I'm gonna go and use 7, 9, and 11 odd exercise on this one. So say if PQ is 7 and QR is 10, this is by segment addition postulate. We know that the distance from PQ plus the distance from QR equals the distance from PR. So in this case, this is just 17. That's it, right? And number 9, again, this PR. Now I have the whole segment is 25. PQ is 12, and I want to find QR. So in this case, I'm just subtracting. So this is 25 minus 12. So it's just 13, right? For number 11, I have PR equals 10. PQ is 4. So QR is 10 minus 4. It's just 6. The same, right? Now on number 12, again, I'm going to go over the odd exercise. So 13, 15, and 17. I want to figure out if those two segments are congruent to each other. So I want to find that distance. So in this case, it's 1, 1, 2, 3, and 4. So distance for GH is 4. The distance from I to K is 1, 2, 3, 4. So that means that yes, they are congruent, right? And this is the symbol of congruent again, right? So number 14, number 15. So IJ is 1, 2. So this is 2, JK. This case 1, 2. So that means that they are congruent to each other, right? And number 17, HK, I have 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. GI, from G to I, 1, 2, 3, 4, 5, 6, 7, 8. So in this case, it's 8. So this means yes, they are congruent to each other. Okay, I'm gonna go over 16 so you can see when it's not congruent. So from H to J, so I have 1, 2, 3, 4, 5, 6. So H, J measure 6. And from G to Y, I have 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. So they are now congruent because they have different measure. Remember the congruent segments, they have exactly the same measure. Okay. Now I'm gonna go to number 19. I have the ST. ST is 3x plus 3. TU is 2x plus 9, right? This little symbol right here means that these two segments are congruent. So T is the midpoint of segment SU. So if this segment is congruent to that one, that means that the measurement, 3x plus 3, are equal to each other, right? So I'm just solving this equation, minus 3. So x equals, 3x equals 2x plus 6 minus 2x. So x equals 6. So, but now I want to find ST. So ST is this one right here. So I know x, so in this case I'm going to substitute. I'm going to do it down here. So 3, so 3 times 6 plus 3. So ST equals 18 plus 3, that's 21, right? So this ST means that is 21. Now I want to find TU. So TU equals 2x plus 9. So 2 times 6 plus 9 equals 12 plus 9 equals 21. So this is also 21. As you can see, they are both exactly the same. They have to be, right? Because that's a midpoint, and they're telling you right here that they are the same. Now, let me erase this so you can have a little bit more space to do the next one. Okay. So number 20 is giving you that ST equals x plus 3. ST equals x plus 3. And TU equals 4x minus 6. So again, I'm going to go x plus 3 equals 4x minus 6. Number 20. So minus, let's go the other way. So plus 6. So x plus 9 equals 4x minus x. So 9 equals 3x. So I divide by 3. X equals 3. So again, I'm going to find ST. So ST equals 3 plus 3 is 9. I'm substituting the x right here. I want to find TU. TU equals 4 times 3 minus 6. 12 minus 6. 6. Wait, right. I have a little mistake right here. Right, this is 6. I'm multiplying instead of I. So again, both of them are the same. That's a way of checking your work. Okay, so now we're going to find the indicated length. In this case, is just indicated by that sign right there. So I know that the segment IK measures 12, JK measures 3, so I'm just missing that one. So this is the same as 12 minus 3 is 9. So this means that this little segment right here measures 9, right? So now when you add 9 plus 3 is 12. See the next one. So again, LJ measure 12, KJ 7. So I'm just missing this one. So 12 minus 7 is 5. So the next one I have. So I have from D to E measures 73 units. From E to F, 3x minus 214. And from D to F, 13x minus 961. And I want to find EF. So I want just to find this segment. But first I need to find x. So I'm going to use the segmentation postulate. So from DE plus EF equals DF. So that means that DE plus EF equals DF. So 73 plus 3x minus 214 equals 13x minus 961. So 3x minus 141 equals 13x minus 961. Now I'm going to subtract the 3x on both sides. So negative 141 equals 10x minus 961 plus 961 equals 820 equals 10x. And now I'm just going to divide by 10. So x equals 82. Now, but that's not the answer, right? Because they're asking me to find EF. So EF is E, F. I'm going to substitute right here on EX minus 214. 3 times 82 minus 214. 246 minus 214 equals 32 units. So this is my answer. Okay. Here I have CB plus BA equals CA. So I'm just going to plug in the information. So x minus 3 plus 10x minus 653 equals 169. So 11x minus 656 equals 6. I'm going to add 656 on both sides. 69 plus 656 equals 825, and I'm going to divide by 11. So x equals 75. Now again, it's asking me to find CB. So CB is right here. So CB equals 75 minus 3. So this is 72. And that's it.